Today we are going to be covering section 7.5. We are going to cover the determinant and Cramer's rule. Make sure that you have enough space for your essential question. You should be able to leave about 2 or 3 lines. Then go and include your cutout and write down example number 1. So go and pause it and we'll continue once everybody's ready. So on example number 1, we have the determinant of a 2 by 2. So the determinant of the matrix is going to be calculated by the following formula. Now the determinant is going to be a number that this formula is going to be giving us. Now there's going to be 2 different ways that you are going to see the determinant denoted as dt in parentheses, but most of the time you guys will see it as an A with 2 bars on the left, on either side. Is that an absolute value? Is the determinant of a matrix. So let's go through. The formula tells you that you'll need to multiply A times D. Then you're going to subtract the product of C times B. And once you subtract it, it's going to give you a number, and that number is called a determinant, and it's going to be bar, uppercase A, and another bar. So let's go to the first one. Example number 1. Find the determinant of each matrix. So therefore, the determinant of A, we are going to take these 2 components, and that'll be 2 times 2 will be 4, minus the product of those 2 components, which will be 1 times -3 will be -3. So therefore the determinant of A will be equal to 7. Sometimes you guys will see it as determinant of A equal to 7. Either way is fine. For purposes, we're going to write down in this using this notation. So try letter B. Go and pause it. Try letter B and see what you get. Excellent. So for letter B, we are finding the determinant of B. First, make sure that you guys are using your highlighter. Multiply those 2 components. 2 times 2 will be 4. We're going to multiply those 2 components. 4 times 1 will give us 4. And we're going to subtract it. So that gives you the determinant of B is equal to 0. Remember, the determinant is just going to be a number that's going to be very useful as we use Cramer's rule to solve some of the systems. So a determinant for a 2 by 2 is pretty easy. For a 3 by 3, we have additional components that we need to talk about. So go and include your next 2 cutouts and write down example number 2, and then we can continue once you guys are ready. Go and pause it, and we'll continue once everybody's ready to continue. So on the cutout that we have above, we have something that's called minor and cofactors of a square matrix. Notice that in order to be able to find the determinant, it has to be a square matrix. So it has to be a 2 by 2, just like example number 1, or just like this one, which is a 3 by 3. So if A is a square matrix, the minor of entry Aij is the determinant of the matrix obtained by deleting the ith row and the j column. So therefore, the minor Mij of the entry Ij is going to be the determinant of the matrix obtained by deleting So we're going to have to delete the ith row in the j column. Got it? So let's go through the first one. So therefore, if I need to be able to calculate the minor 1, 1, I want you guys to circle A11, and it says that we are going to delete the row and the column where that is located. So therefore, I'm going to take and I'm going to delete those two. And what I end up with will be A2, A22, A23, A32, A33. Then we are going to calculate the determinant of this. Now, if you guys can do me a huge favor, this one should be blocked. Now, whenever you find the difference between a bracket and a line, is that in this case, this is the determinant. We need to be able to find the determinant, and we're going to do that on example number 2, where we find, now that we have this, we are going to go through a process, just like we did example number 1, and we have to find the determinant of that matrix. And that's why you guys see the bars instead of the brackets. And I missed this bracket here. So a bracket means that that's the matrix. If you have the 2 bars, means that that's the determinant, just like example number 1. Now, to be able to find the minor of 2, 1, we're going to go through the same process. We're going to circle 2, 1. And once again, I'm going to delete the row and the column. So I'll delete the row that number is located in the column. And what I end up with is A12, A13, A32, A33. Then I am going to remember that we have the 2 bars, so therefore that indicates that that is the determinant. And I'll go through the same process to be able to calculate the value. It's going to be a number. And for the last one, I'm going to circle 3, 1. And I'm going to delete the row and the column where it's located. So therefore, what I end up with is A12, A13, A22, A23. So that is the minor. Now we also have something that we call a cofactor of Cij. The cofactor of the entry, of any of those entries, will be -1, and you're going to add, as the exponent, you're going to add the I plus j. Then you are going to get the value that you get from the determinant, and you're going to multiply. And that's going to help us find the determinant of a 3x3 or a 4x4. So the determinant of a square matrix is the sum of the entries in any row of A multiplied by their respective cofactors. And they give you a formula. They give you A11, so you're going to multiply that number. So in this case, the number that's located here is A11. And you're going to multiply by the cofactor. Now remember, the cofactor has 2 components. Has -1, I plus j. In this case, I and j is 1, 1. And the minor. Notice that I prefer to do this separately, where in some books they'll ask you to find the cofactor and then plug it in. So therefore, I prefer to just use this equation to be able to find the determinant. And it'll be the same thing for the next one. You have the second term is here, A12, whichever number that is, and then you're going to multiply by the cofactor, and I prefer to separate first the -1 to the exponent of 1, 2, and the minor 1, 2. And then we're going to continue all the way to the very end. So now let's go through example number 2. Let's find the determinant of a 3 by 3. Notice that to find the determinant of a 2 by 2 is a very easy process. To find the determinant of a 3 by 3 it gets a little more tedious. So first, I'm going to find the determinant of A. First, you need to decide whether you want to use the first row, the second row, or the third row. Or you can decide to use the first column, the second column, or the third column. It'll give you exactly the same answer. So do you guys want to work with the rows or the columns? Perfect. Rows. You need to decide you're going to use the first row, second row, or the third row. Now I'll give you guys a hint. I prefer to use the one with the one that has the most zeros or the one that has smallest number. So in this case, I see the row number 1 has a 0, but also row number 3. But number 1 has smaller numbers, so therefore I'm going to use row number 1. So I'm going to highlight. I'm using row number 1. And I'm going to start with the first number, which is 0. Now your formula tells you it's going to be -1. And this is the first row and first column. So therefore this term is 1, 1. So exponent will be 1 plus 1. Then it says A11. So it's actually the number itself, which is 0. Then the minor of A11. Now we can find the minor just like we did here, where we're going to be deleting the row and the column. So therefore, if I need to be able to find the minor of 811, I am going to delete the first row and the first column. So therefore, the numbers I end up with is going to be a matrix. It's going to be the determinant. I'll place my bar. It'll be -1, 2, 0, 1. And I'm going to do the same thing with the next number. So I'm going to continue with the next step. The next number is 2. We're going to start with plus. It'll be -1. This is the first row, second number. This is 1, 2. So it'll be first row, second number. Then the number itself, which is 2. Now the determinant, you're going to delete the row and the column. So it'll be 3, 2, 4, 1. And now we're going to go through the next, which is just the 1. The 1 is, so it's going to be -1. And it'll be the first row and the third column. Then the number itself, which is 1. Then the determinant of the matrix that you get by deleting the first row, or the row and the column where the number is located. So in this case, there'll be 3, -1, 4, and 0. And now I just need to be able to simplify this expression. So I finish all 3. 1, 2, 3. This is -1. 1 plus 1 is 2. And the 0 stays there. Now the bars means that I need to take the determinant. So therefore I'm going to multiply -1. -1 times 1 is -1. Plus, minus, correct? This will be 0 times 2, which will be 0. Let me simplify this. So this gives me -1 to the second power is +1 times 0. And -1 minus 0 is -1. So therefore the first is 0 plus. Now let's simplify the next one. -1 to the third power. Then we have a 2. And I'm going to find the determinant of a 2 by 2, which is the easy part. That is 3. And that gives me 8. So it'll be 3 minus 8. Plus -1 to the third power will be -1 times 2. And 3 minus 8 will give me a -5. And let's simplify the last one. So simplify the last one, see what you get. Or let me actually just simplify this. So this gives me -2 times -5 is +10. This gives me, try the last one, see what you get for the last number. And then we can add those 3 numbers together, will be the determinant of A. Go and pause it and see what you get. Excellent. So in this case, this is -1 to the fourth power, which will be +1 times 1. And I'm going to find the determinant, which is 0 minus -4. So it will be 0 minus -4. So therefore, this gives me 1 times 1 times +4. So this gives me 1 times 1 times gives me 4. So therefore, that'll be 14. Now let's go and get our calculators and confirm that this is a determinant. We started doing this last time. If you are at my 0, then we can do this when I come back tomorrow. But if we know how to, if you can get your graphing calculator, most of you guys have the TI-84. So therefore, I'm going to go under matrix, second matrix. I'm going to go under edit, and I have a 3 by 3. So it'll be 0, 2, 1, 3, -1, 2, 4, 0, 1. Once you have a set, we can find the determinant. So go and pause it. See, make sure that everybody has it on their calculator, and then we can continue on. Excellent. So at this point, now that you have it on your calculator, I'm going to go ahead and double check that everything's fine. Looks good. I'm going to quit. I'm going to go under matrix. I'm going to go under math, and the first one's a determinant. And I'm going to go under matrix again, so I can select the matrix A. I'm going to close my parentheses, and that should give me 14. So therefore, your calculator will do all the work. So I know what you guys are thinking. So why should we do this by hand? Because this will be on your test. You need to be able to understand the process, not just what your calculator gives you. So let's try example number 3. Now remember that on your homework, I do expect to see all the work. If you just give me the correct answer, you're going to get a 0. So copy example number 3, and we'll start the process together, and then we'll compare our answers. But let's start the process together so we can go through the same steps. Go and copy it, pause it, and we can continue. Excellent. So find the determinant. And now what you guys are thinking at this point, you can say, yes, I can just use my calculator. So my calculator matrix, I'm going to go and edit. And I'm going to type in my 3 by 3, which will be 3, 4, -2, 3, 5, 0, -1, 4, and 1. Then I'm going to go quit. I'm going to go under matrix, math, determinant, matrix A, and it gives me -31. So your answer should be -31. So let's go through a process. First, you need to decide which row and which column you're going to use. So you can use the first row, second row, or third row, first column, second column, or third column. Which one do you guys prefer? Perfect. So we are all using the column number 3. Good choice. So we have, I'm using the third column, but if you use the second row, it's fine. You get exactly the same answer. So first, we have the determinant of A equals. So therefore, we're going to start with -2. Now remember, your formula tells you that we're going to start with a -1. So this will be -1 to what exponent? This is the first row in third number. So this will be 1 plus 3. Then the number itself, which is -2. Now you are going to find the determinant of the matrix that you get from canceling the first row and the column number 3. So we end up with 3, 5, -1, and 4. And I actually just like to simplify as I go through the process. So this gives me -1 to the 4th power. This gives me -2. And now I am going to find the determinant. And notice that I highlight because visually it will be less things for me to remember for this test. So therefore there'll be 12. You have to go down first. 12 minus -5. So therefore this gives me 1 times -2, and this gives me 17. So therefore this gives me -34. Plus, go and find the second component and the third component, and then we can check our answers. Go and pause it. We'll wait until everybody's finished, and then we can continue with the process. Go and pause it. Excellent. So in this case, I'm going to have a plus -1. I'm going to use the second, which is a 0. This is on the second row and third column, so therefore second row and third column. The number is 0. And as soon as I see the number 0, basically I'm done. I know that this is going to be a 0. Do you guys agree? But if you were going to find these numbers, I'm going to cross my second row and my third column. So I end up with 3, 4, -1, and 4. And that's what we usually prefer. If he has 2 zeros, it'll be even easier. But in this case, this one has only 1. And I can go through the process, but I don't need to continue because anything multiplied by 0 gives me 0. This will be -1, and I'm going to continue with the next number, which is 1. So this is my third row and my third row and my third column, so it'll be 3 plus 3. So therefore this will be -1 to the 6th power. Multiplied by the number itself, which is 1. And last, I need to find the determinant of the matrix that I get when I delete the row and the column. So therefore this will be 3, 4, 3, 5. And now I'm going to find the determinant, which will be 15 minus 12. So this will be 15 minus 12. So therefore, -1 to the 6th power is +1 times 1 times 3. So this gives me +3. And this is -34 plus 3 will give me -31. And according to calculator, that is the correct answer. So just be careful. This is very detail oriented, so make sure that you keep track of your signs. If you highlight, circle, you can use spaghetti bars to be able to work through the process. It makes it a little bit easier. Now, why do we use determinant? So determinant is going to give us another way to be able to solve 5, 4, 3, 2, 1. So now that you have example number 4, let's go through the cutout. Cramer's rule. Cramer is a famous mathematician that developed this rule that says if a system of equations has a coefficient matrix A, so if you have a system of equations, then our matrix A will be by the coefficients, and the matrix itself will be A11, A12, A21, A22. And notice we can find the value of x and the value of y. But first find the determinant, and it'll be on your denominator. Next, you are going to replace, if you're trying to find the x values, you're going to replace this instead of the x values. So therefore it becomes b1, b2, and those two stay the same. If you're looking for the y value, then I'm going to replace the y value with b1, b2, and a1 and a21 stays exactly the same. You got it? So let's go through a process. Use Cramer's rules to solve the system. And I know some of you guys will say, well, can I just use combination? You'll get exactly the same answer. But in this case, they are asking you to use Cramer's rule. Some of you guys will say, can I just use substitution? You'll get the same answer, but we need to use Cramer's rule. So in order to use Cramer's rule, first I need to be able to find the coefficient matrix. So I'm going to use, and I'm going to have to find the determinant. Well, let's go and write down the unit. So it'll be 4, -2, 3, -5. So therefore, the determinant of A will be equal to 4, -2, 3, -5. Notice the difference. Then now we have a bar. So if you want to skip that step, it's fine. And now I'll find the determinant. So therefore, that gives me -20 minus -6. So therefore, the determinant of A is equal to -14. And now I can find my x value and my y value. According to this, each one is going to be divided by the determinant of A. So in this case, it will be -14. And now we're going to find the determinant. But because we're looking for the x, the 10 and 11 will replace the 4 and the 3. So now we're going to have 10 and 11 replace the 4 and the 3. So now we still have a -2 and -5. Whenever we're looking for the y, the 10 and 11 is going to replace the y value. So therefore, when I'm looking for the y, it's going to be 10 and 11, and the 4 and the 3 stays the same. Notice that I'm placing bars because I need to find the determinant, where we already found the determinant of A, and we just place it underneath. So now I'm going to multiply -50 plus 22. So this will be -50 minus -22. So therefore, that gives me -28. My denominator is -14. So therefore, x is equal to +2. Isn't that amazing? So therefore, I'm going to find the determinant. So that gives me 44 minus 30, which is 14. My denominator is negative 14, so therefore that is negative 1. So therefore my solution for this system is x is 2, y is negative 1. If you have done it by combination, you've gotten exactly the same answer. If you've done it by substitution, you've gotten exactly the same answer. If you've done it by graphing and graphing on decimals, it should cross at this specific point. And if you want to check, we can just plug into the first one to the second one, and it should give us a true statement on both. But for now, let's move on to the last example of today, example number 5. Now we're going to find Cramer's rule. We're going to find the solution of a 3 by 3 using Cramer's rule. It'll be exactly the same process. Go and copy it down, and then we can start. Excellent. So first, I need to be able to find the determinant of matrix A. So therefore, I'm going to find matrix A is a coefficient matrix. So therefore, it'll be negative 1, 2, negative 3, 2, 0, 1, 3, negative 4, and 4. I should double check to make sure I copy everything correctly. And now I'm going to find the determinant of A. And actually, let me just go all the way to the left because I probably need some more space. So we're going to do the same thing that we did on example number 3 and example number 2. So I'm going to find the determinant of A. So we need to decide, are we going to use the first row, second row, or third row? The first column, second column, or third column? You get exactly the same answer. So what is your vote? Correct. Let's use row number 2. So find the determinant, go and pause it. Everybody's working on the determinant, and we can check our answer afterwards. You can go and pause it. Excellent. So now I'm going to use my second row, and I'm going to start with my 2. So therefore, this will be negative 1. The location of 2 is my second row and first column, so it'll be second row and first column. Then the number itself, which is 2. Now I'll find the determinant of the numbers that I get when I cross out my row in my column. So therefore, that'll be 2, negative 3, negative 4, and 4. Let me simplify this out. So it gives me negative 1 to the third power, which will be negative 1. And this gives me a 2. This gives me a positive 8 minus 12. So this gives me a negative 1 times 2 times a negative 4. So it'll be positive 8. Plus. The second number is a 0. So therefore, that'll be 0, 0, 0. I don't have to do any work. You can if you want. And the last number is, let me start with plus a 1. So therefore, the location of the 1 is the second row in the third column. So it'll be second row and third column. Then we have the 1. And we are going to use our matrix that we get. We're going to delete the row and the column. So therefore, it'll be negative 1, 2, 3, negative 4. And now I can simplify this. Negative 1 to the fifth power will be negative 1 times 1. This will give me positive 4 minus 6. This is negative 1 times 1 times negative 2 will give me positive 2. So therefore, that'll be 10. Now that I find the determinant of A of the coefficient matrix. So this is a coefficient matrix because we got all the coefficients from all the variables. So that's why it's called a coefficient matrix. Now we can find the value of x. The value of x will be divided by 10. The value of y will be divided by 10. And the value of z will be divided by 10. But now we have to find the determinant of the coefficients. Well, actually, we are going to replace 1, 0, and 2 instead of the x's. I probably need just a little more space to give myself a little more space on this. So therefore the 1, the 0, and the 2 is going to replace my x. So therefore the rest will stay the same. 2, 0, and 4, negative 4, negative 3, 1, and 4. And now I'm going to do the same thing for the y. It's going to be divided by 10. I want to find the determinant. Notice that I'm going to place a bracket because I'm going to find the determinant. But now the 1, 0, and 2 is going to replace your y's. And the other numbers will be negative 1, 2, and 3. And negative 3, 1, and 4. And now set up your z. Z what you get. Divide by 10. And now you have to calculate the determinant for the first one. Yeah, I know it seems like a lot of work, but it's not. It's easy. Very straightforward. You just have to follow your formula, your process. You will have to memorize your formula. So let's do x together. First, you get to decide, do you want to use the first row, second row, or third row? First column, second column, or third column. You get exactly the same answer. So what is your choice? Perfect choice. Second column it is. What do you guys select the second column? The second row? Select the second row because you have 2 zeros. So the only thing that I have to do is 1, negative 1 to the what power? The location of the 1 is my second row, third column. The number itself, which is 1. And now I'm going to get my determinant of the matrix that I get when I delete the row and the column. That gives me 1, 2, 2, negative 4. So therefore negative 1 to the fifth power, it will be negative 1 times 1. This gives me a negative 4 minus 4. So therefore this gives me negative 8 times negative 1 is positive 8. So it'll be 8 divided by 10. So therefore 4 over 5 is your x value. Now go through the same process. Find the value of y, find the value of z, and then we can compare answers, and then we'll be done for today. Go and pause it. Excellent. So at this point you should have it done. So I know it's going to be divided by 10. I'm going to use my second row, and I'm going to have negative 1. This is my second row, first column. Second row in first column. I'm using the 2. And I'm going to delete. So that gives me 1, negative 3, 2, and 4. And that is if I delete this. Correct? And that gives me negative 1 to the third power will be negative 1 times 2 will be negative 2. This will give me 4 minus negative 6 will be plus 6. This will be negative 2. This will give me 10. It will be negative 20. Remember, we're not done yet. Now we're going to continue with the 0, which will be just 0. We're not done yet because now we're going to continue with the 1. So therefore be plus negative 1. This is my second row, third column. Second row plus third column. Then I end up with a 1. I'll place my matrix that I get. I'll find the determinant. I'll cancel my third row, my second column. So I end up with negative 1, 1, 3, and 2. So it gives me a negative 1 times 1. This gives me a negative 2 minus 3. This will give me negative 1 times negative 5. So we plus 5. So therefore, my y value is going to be negative 15 divided by 10. So therefore, it will be negative 3 over 2. So therefore, after making a few corrections, my answer should be negative 8 over 5 for my z, my y, and my x. Now, if you want to type into your calculator, we can actually go through process and type in. So if you were in my 0, in my period 3, we did this before. If not, we'll do it next time on your calculator. We go under matrix. I'll go and edit. I already typed it up. Negative 1, 2, negative 3, 0. Then notice that I'm using my augmented matrix, so I'm also placing my constant. I quit. I go under matrix, math, and I want to go under reduce row echelon form. My matrix is A. Close my parentheses. And if I need as a fraction, I go math, number 1, and it'll transfer into a fraction. So therefore, this is my x, that's my y, and that's my z. So that is the lesson for today. I'll see you guys next time. And I'll post the video online in case you need additional help.